Okay, a quick review of how to complete this observing how plates move activity. So this is the one you did together with a partner in class today. Directions are on slide 2. Data collection is on slide 3. I already have the simulation open. If you don't have the sim open yet, it's linked in step 1 of the direction set. So make sure you have the simulation open. Remember that when you log into Amplify, you'll need to use the log in with Google button to get yourself in, and then you'll use your school email address. Direction 1, open the sim, check. Direction 2, go to region 2 of the simulation. Direction 3, add a GPS marker to each plate boundary as close as possible to each other and to the plate boundary. So what that means is you're going to drag these markers here and set them on either side of the plate boundary, but as close as possible to the plate boundary line and one another. So you want them to be from the starting point very close together. As close as possible, but they have to be on opposite sides of the boundary line. If they're not on opposite sides of the boundary line, this activity won't work. Press set boundary and select divergent as the plate boundary and then run. Set, divergent, run. So I'm going to pause here so we can read the next direction set because I know there are some more directions. During the run, press pause approximately every 50 million years. Record the time in the first column of the table below. Observe the distance between the two pins by pressing on either pin and reading the distance to the other, and then record that number in the distance column. You can press the reset button in the top right corner to replay the sim. So here's my plate motion sim. It's running. I need to pause at the 50 million year mark. And again, the time is up here in the corner. I'm not even worried about how far away they are. I'm just worried about pausing at 50. Now you'll notice I hit 51. There's no need for me to restart and hit 50 exactly. 51 is close enough, but what I need to do is in the first column of my data table on slide 3, instead of saying 50 million years, I need to write 51. So it's okay if you're off by a million or 2 years here, but you just need to make sure to record the accurate number in your data table. Now the next step is where I think we had some mistakes today in class. So what you're going to do next is click on one of the markers, and you're going to see two values here. The first value, 585, is telling you how far the marker is from the boundary line. That is not the value we want. The second value tells you how far the marker is from the other marker. That is the value that we want, 1,241 kilometers. In the distance column, I'm going to write 1,241 kilometers. So again, when you click one of the markers to find distance, there are two values. The top value is not the value we want. The bottom value, which tells you the distance from one marker to the other, is the value we want. It should be the larger value. So again, I put that value in my table. Now I'm only going to do this activity once for you as an example, so let's just jump straight to rate. I need to have a calculator open, and what I'm going to do is just go to Google Classroom and type calculator. And then what I need to do, according to the directions here, rate can be calculated by dividing the distance by the time. So distance comes first, and I'm dividing it by the time. So I'll go to my calculator. Distance was 1,241 kilometers. Oops, 1,241 kilometers divided by 51 million years. 24.333 repeating. You can go out 2 decimal places and you'll just round that second decimal place. Remember, when we round, we look to the number to the right. So if it's 4 or below, it tells me to round down. 5 and above tells me to round up. So this 3 is going to stay a 3, right? 24.33. 24.33. That's my rate. And again, that rate is calculated in kilometers per millions of years because we took the kilometers and divided it by millions of years. 24.33 is my rate. Should be somewhere between around 21 and 26. If it's not between 21 and 26, you need to go back and recalculate. You'll notice you have 4 rows on this table. You need to do this 4 times. So your next value should be around 100 million years, and then 150, and finally 200. In order to find those values, you'll just return to the simulation, keep the sim running until it hits about 100 million years. And again, I'm 1 over, which is fine. I just need to make sure that here I actually make this accurate. So it's 101. And then again, find the distance. It's the second value, 2365, recorded in your table, and calculate your rate, dividing the distance by the time. You'll do that for all 4 rows. Once you've done that, you should get 4 rates that are very similar. If your rates are vastly different, off by more than 1 or 2, you should go back and recalculate. Your rates should be very similar. After you've calculated all 4 rates, then you can jump down to slide 4 and answer the question on slide 4. Question on slide 4 is asking you which claim you believe is more accurate based on what you found in your data table. All right. If you have further questions, feel free to stop by office hours. They're at 1 o'clock today, and I'd be happy to go through this with you one-on-one if you need help. But make sure before you seek help that you've watched this video.